afternoon, everyone, and welcome to this enlightening session on 3D printing and its transformative impact on manufacturing and construction. Today, we are privileged to have Mr. Swapnil Sansare, a trailblazer in the 3D printing industry and the founder and CEO of Divide by Zero Technologies. With over 17 years of experience in manufacturing and additive technologies, Swapnil has been at the forefront of democratizing 3D printing for startups and established enterprises. Under his visionary leadership since 2013, Divide by Zero Technologies has emerged as a pioneering force, delivering cutting-edge 3D printing solutions tailored to diverse industrial needs. His previous roles, including managerial leadership at LabGuard India and contributions as VP at the India Additive Manufacturing Forum, have further cemented his reputation as an innovator and thought leader. In today's session, Swapnil will guide us through the possibilities unlocked by 3D printing, how it enables on-demand manufacturing, reduces lead times, minimizes industry costs, and fosters a culture of rapid prototyping and customization. He will also delve into emerging business opportunities, from personalized product creation to the exciting realm of small batch production. Please join me in welcoming Mr. Swapnil Sansare as he takes us on a journey of unlocking business potential with 3D printing. Welcome to MSME Masterclass, Swapnil. We are pleased to have you.
Thank you for having me here, Amrita. So, it's my pleasure.
Swapnil, our first question for today's session for you is, what are some of the most surprising uses of 3D printing that have emerged in the past few years?
I think, it has been a journey, where we have seen very new applications coming every month now with 3D printing. Especially, very surprising to me was, gourmet meals and space exploration, where 3D printers are being used to deliver, develop, food, and that too gourmet food, pizzas, or maybe, even 3D printed meat, vegan meat as well, versions of it. That was very surprising. Beyond that, I think I've seen some of the case studies in ancient heritage sites where they're trying to restore lost artifacts with construction 3D printers or with standard 3D printers also. So with the help of AI and 3D printing, they're actually able to trace down the missing pieces and then rebuild and the whole damaged or lost component or part of the structure. Beyond this, I think 3D printed houses are something I see as a big market now and growing very aggressively, because earlier it used to take months to build a house, but with 3D printing already in India, I see with a lot of organizations, even with defense now, they're using 3D printing for building houses or bunkers or schools or hospitals in remote areas also. And that too, when I saw this personally, this was being built within few hours, 8 to 10 hours. And that was very, very, new to me, because I thought it will still take few days and, weeks maybe, but this was taking hours. And this builds a lot of value, because especially where you have maybe, areas where you have any natural calamities, maybe, flood or maybe any other problem like that, where you can build hospitals or maybe, restore schools or maybe housing very quickly, and that would be game changer. Prosthetics and implants, it was always there, but now it is becoming very, very accessible, because software, especially 3D scanning and 3D printing softwares, are more and more accurate now. They are approved by FDA or such governing agencies and other agencies also, and wherein now they are you can see such prosthetics being used and developed and delivered globally and at very affordable cost now. Bioprinting also has been very, very aggressive, and tissue 3D printing and organ is something which is very complex and it will take to develop, but tissue printing is taking it's groundbreaking right now, because especially with deeper wounds, especially for military or defense purpose people, or maybe any other application, that has been also a game changer. So these are some of them. There are a lot, but yeah, these are what I can think of right now.
Swapnil, could you also tell our attendees how can businesses tap into the potential of 3D printing to offer highly personalized customer solutions?
So see, when you look at highly personalized, end customer solutions, there are areas where you can get into. Especially, we call it hyper customization, or we also call it mass customization in 3D printing terms. When each and every component that you build on a 3D printer has unique design, and that's where it is very different from traditional manufacturing, because with traditional manufacturing each component is similar. Maybe if you talk about a shoe, it is going to look like same for all. Maybe there is a size difference, but there are going to be batch of maybe 8 numbers, 9 number or 10 number shoe. But with 3D printing, if I say complete customized solution, if I'm delivering a 3D printed shoe, it's going to be completely customized as per arches and shape of your feet, specially developed for you. And now this kind of brings in more comfort, more I would say efficiency, and also a way wherein patients or people can feel more comfortable. Athletes can use these shoes. Now this is an example of, as I said, personalized customization. So in this area of healthcare right now, because it's being a huge area where value is more. So surgical guides are there, implants and prosthetics area is there, where it's specific to the patient or the person. It cannot be the standard for everybody, and that's where there is huge business potential. Again, orthotics or braces are there. These are areas in healthcare. Maybe in terms of footwear industry, it's $1 billion industry, and 3D printing is revolutionizing footwear industry in big way right now. I know at least 3 companies which are letting you scan your feet with a normal phone app, and they deliver a 3D printed shoe fit to your design, and maybe you can choose the color, you can choose the texture, and it will be delivered. It's going to be big for sure in coming days. Consumer electronics, so especially customized phone cases and wearables and all that high-end sports wearables, especially are there. It's a niche market, but again, that is something you can look into. Already, 3D printing was part of jewelry industry since long. A lot of big companies in India already they were utilizing 3D printing for jewelry, and we all love to have our own unique design and say, okay, this is not available, especially with women. They would love to have their own unique set of designs, and that is where 3D printing can play a big role. When I say customization here, what happens is the mold that was required earlier for making a jewelry piece was not required with 3D printing. They can just 3D print a wax model and get it, converted into a, say, silver or gold, or and then maybe deliver that. So now making these custom designs in batches is becoming a big market. And again, India is, I guess, an exporter of a lot of these such jewelry pieces. I can see huge export happening directly of such jewelry pieces, or even specially design or maybe wax models also from India. Beyond this, I think eyewear is something which is growing, but again, it's a niche market. Eyewear for specially able people, and maybe people who would want to get a special eyewear done according to their face size and fit and everything for comfort. But in all these areas, there is a need for all of us to have something customized, have a special, design, and that is something which can be handled with 3D printing. Why these areas, of customization or personal customer-based solution is thriving is because it lets the user choose how they want that part to look like, or maybe it is helping them personally, so there is much greater value. And in terms of margins or bottom line, a lot of these businesses are doing good, and it is something which is changing the game for the businesses also. They're thriving right now in this area.
Correct. Absolutely right. Now, Swapnil, moving on to the key advancements part of it, could you tell our attendees, according to you, what are some of the key advancements that have happened in 3D printing materials that are opening new manufacturing opportunities and avenues for people?
So, in terms of 3D printing, there are basically a lot of new advancements. First of all, material side. So when you talk about material, earlier it was only restricted to polymers or plastics. Now you can 3D print in ceramic. Now you can also 3D print in glass, metals, and I think there are wood-based composites. Again, these are plastic plus wood, but composites. And then again, there are elastomers or rubber-like materials also. So this gap between demand and supply in terms of various materials is closing in, and high performance polymers are actually changing the game for 3D printing. Because when you talk about standard molding polymers or machining components, even metals, you cannot use the same metal or materials which were used for traditional manufacturing for 3D printing. They need to be, basically customized, or maybe the chemistry needs to change in order to use these materials for 3D printing, because as it is a layer by layer process, that material optimization and the whole characterization is completely different. And that's where, this advancement right now is something which is there in terms of material that I see. Beyond this, I think there are biocompatible, and again sustainable materials. Both are available, and that is also driving healthcare sector in big way. Biocompatible, especially recycle, and sustainable materials. This area, again, a lot of companies, they have tons and tons of wastage coming through, and that. With strict government norms right now, even in India, they have to recycle that material or ensure, their plastic wastage is minimum. A lot of them can now recycle these, basically wastage and build benches or anything. I've seen some of the companies doing that now out of their 3D, out of their plastic waste. Beyond this, on the material side, in terms of electronics, you have ESD safe material. So earlier, it was not possible to develop end-use electronic products with 3D printing, but that is completely possible now. So more and more 3D printing is moving towards on-demand manufacturing, and that something is changing the game in the coming years. I think there will be 3D printers challenging, or maybe next to standard manufacturing machines, and they'll be working in tandem. Both technologies together.
Moving on to our next question, Swapnil, which is to do with on-demand 3D printing. Do you think it reduces overproduction and inventory management risk? And if so, how?
See, on-demand 3D printing definitely reduces overproduction and inventory management risk. But it needs to be applied where you have mass customization. When I say mass customization, when you have each product has a different design and that needs to be manufactured, 3D printing will make sense there rather than making a same component 10,000 times, because that's where your traditional manufacturing is going to work, and it will have less cost. However, areas like as we discussed, some of the applications, healthcare, or maybe some automotive company who has the spares and consumables that they have to keep in stock for older cars, maybe which are like 10 or 15-year-old models, and they have a mandate to hold these spares for certain amount of years, maybe 20 years by mandate. In that case, they can actually hold the designs, 3D print it whenever the requirement is coming in, and deliver. So, what 3D printing is doing is it is reducing your inventory carrying cost. First of all you have to do is you need to have 3D printable models. You have to have the raw material, and whenever the order comes in, you can fire the 3D print. This also gives a lot of flexibility, because I've seen some of the companies, they have headquarters, say maybe in Delhi. Now they have a service center in Bangalore, or maybe in Mumbai, or maybe in Chennai. If at all there is a component that they need to deliver, they don't need to ship it from Delhi to Mumbai or Delhi to Bangalore. What they can do is they can just send the design from Delhi head office to a 3D printer in Bangalore. It can 3D print that, and from there it can be delivered immediately to the customer. So the whole agility of supply chain is really good. Secondly, a lot of these components have shelf life. and then after the shelf life, the component it has to be scrapped. Rather with 3D printing, you're not wasting that. That wastage can be again reduced. As I said, localized production is possible, and beyond this, design freedom is there if there is a better version of the same component that is coming through. A lot of the small business owners we have seen, they would want to get rid of the existing design and whatever the stock they have for the old design first, and then bring in the new design. But then that also has a risk of running through bad design and maybe facing same issues or problems with the design change, whatever they were running. But with this, they can actually update the design in the digital inventory and directly fire through the 3D printer. So the newer designs are available all the time for the customer. So this is going to be, great advantage, and this is how I see, on-demand 3D printing will reduce inventory management risk for sure.
Could you also help us understand some of the innovative approaches that businesses these days are taking to integrate 3D printing into traditional manufacturing systems?
In a way, 3D printing, as I said, cannot replace traditional manufacturing right now when it comes to mass manufacturing, or when you have one component that is made for thousands or lakhs of units or times again and again. However, especially when it comes to tooling, so jig fixtures, or maybe different types of tools which are required for manufacturing are completely I've seen industries or assembly lines changing from CNC machine fixtures, which are aluminum or maybe cast nylon based fixtures, to 3D printed fixtures now. Because with traditional manufacturing, if you make one or two of components, their setup time and initial cost is so high that 3D printing, you have cost saving of almost 30 to 40% in the initial material cost, and on the timeline it's almost 10 times because of the initial setup time and the coding and programming and everything. So all in all, it comes down to 1/3 of the cost when it comes to jig fixtures for assembly fixtures and production lines. I've also seen a lot of companies using automotive companies using the repair and replacement parts which are 3D printed on some of the high-end technologies, and this is where they kind of can provide on-demand component. Now, if I have to say maybe get a component for my say maybe very old German car from Germany, they can provide me that part, but my import duty and custom duty is going to be so high at the end of the day. Rather, I would just get it here. That company can 3D print it here and deliver to me at much lesser cost, and even the turnaround time is much lower. So this is something which is happening. Very new approach wherein we also worked with a lot of companies was hybrid systems. When you have 3D printing and CNC machines coming in together. So with 3D printing, because it's a layer by layer process, it can build component really fast. So with 3D printing, you build a neat shape of the component that you want to build, or a tool. But if you need a very high precision or super finished component, you can also use a CNC machine and finish that component. And this is called hybrid. So it has got best of both worlds. You have got speed of 3D printing, and you've got finishing of CNC, or and accuracy of CNC. And that is something which I see it's happening in aerospace. It's happening in automotive in big way. That's there. And I think digital inventory and distribution manufacturing, as I said, that's big way for sure. As I said, as we already discussed, there are brands, especially now coming in. You can see them. You can Google search. Even small businesses have started in India. They are making small lamps. They are making small artifacts and desk accessories out of 3D printers, and they are selling in thousands and thousands of numbers. And you can't tell they are 3D printed. They are that good. Okay, and they are making it out of certain machines, and they have developed their own post processing. But this is really inspiring. And also, I think in terms of innovative approach, one last thing is sustainability and waste reduction. So if at all, we've also seen a lot of these companies again working on recycled polymer material, getting it to on a basically palletizing that again and using it on a 3D printer, which is a large scale machine, and building components again out of those. So this is again a big game changer, I can see. But yeah, these are some of the I would say traditions or maybe innovative approaches over traditional approaches I can see right now.
Moving on to advancements in multi-material 3D printing. How are these enabling more complex and functional products according to you?
So when you say multi-material 3D printing, I can see that this is being used mostly in electronics industry. 3D printing for electronics is going to be big. Like when I say electronics, it's not just electronics enclosure, but building actual electronics component, maybe a complete circuit, including transistors, resistors, or capacitors on the go in 3D printing. And this is coming in big way. I can see a lot of movement happening here, and multi-material 3D printing especially is going to revolutionize electronics industry when you can print circuits directly on flexible substrates or PCBs with both conductive or insulating materials in one step. So that is actually game changer. However, it basically lets you integrate multiple materials with different properties. Maybe I can have a stiff component and a flexible component. And maybe combination of that in terms of geometry, helps me maybe dampen certain vibrations in certain component, maybe automotive, or maybe helps me, build a component that was not possible by traditional manufacturing methods. So this is something which is happening. I can see some of the shoe companies already adopting this, wearables or medical devices, and again aerospace, yes, in big way. Another area which I could see was, prosthetics and orthotics, where say maybe if in prosthetics, if there is an amputee and who needs basically a prosthesis or a device, needs to have a flexible or a softer element and a harder element, softer to kind of grip the skin or the region, and the harder element where they're actually connecting the rest of the device, I would say. So this is going to be a complete way where multi-material 3D printing is going to change. But again, this is a big subject area, maybe, but this is where I can maybe give you a smaller way here. Yeah, that's it.
How can Swapnil startups overcome the perception of high upfront costs associated with 3D printing?
I think startups need to understand that when they say high upfront cost, okay, they look at the cost of owning the 3D printer, or maybe setting up the 3D printing service, or maybe having their own in-house 3D printing service system. They need to understand that unless they have a market ready, my recommendation would be they can look at going for print services as service bureaus as an option, because that kind of gives them a time to test, or maybe their ideas and how the market is responding to their ideas. But once they're sure that they have market for their product or whatever they're developing, owning a 3D printer becomes much easier option. However, it comes with some initial cost, same as you put in any machinery, or maybe investing into any capital equipment in your shop floor. However, this upfront cost, if you try and look at most of these 3D printers, even to the range of say maybe 2 to 20 lakhs, are available. 90% of printers available are in this kind of price range. Your ROI period is going to be less than 6 to 8 months. And for that, you have ROI calculations. And if that period, 6 to 8 months period is something which you can see, you should go ahead and invest. However, if at all that period seems bigger or greater than 2 years, they should still hold on and get the services. Usually, we have seen a lot of companies, getting in and their ROI time, is a hardly 4 to 6 months time, and that is where they get a lot of advantage. Another thing is, with 3D printer, owning 3D printer, uh, most of the times their design team is dependent on external vendors and whatever tooling is available with them, or whatever materials, even with outsourced 3D printing services, whatever type of material is available with the service provider. Now here with in-house 3D printing, they can actually play around and look at or try various designs and iterations, and that kind of also drives or gives them leverage in terms of design iteration and coming up with newer and faster and better solutions. So that is important. Also, I think if at all they feel that this cost is going to be huge, we have also seen some of the companies, maybe 3 or 4 companies, coming in together and building strategic partnerships, wherein they kind of say maybe 4 companies buying in one 3D printing, setting up one 3D printing setup, and wherein they have the machine, the person who's going to handle the machine and post-processing unit in one place, and all of them utilizing this. So this also can help them. And also in a way, I think there are also forums, or maybe forums like this where you are sharing knowledge. A lot of information is being shared. There are a lot of government schemes wherein they can get subsidies on buying new 3D printing equipment or machines. So that also they can maybe make use of. So yeah, I hope I've answered the question. Yeah.
You have. Thank you. Now, according to you, Swapnil, how are businesses overcoming speed and scalability limitations in 3D printing for large-scale operations and productions?
So 3D printing, speed is something which is very, very relative term, because what are you comparing this with? When we say, I'm comparing maybe a component I want to make, maybe a manifold or a particular component I want to make on a 3D printer and a CNC machine. On a CNC machine, before you make that component, you need your preform or the basic component, or metal, or wooden or plastic, whatever basic preform. Then you need jigs and fixtures, and you need tooling, different tools altogether to machine that part. And to source all of it is going to take at least a week or two prior to starting your job on a CNC machine. And then there is a code that you have to deliver, or G code, or NC, or we call it CAM. With 3D printing, if I want to start printing a part, if I have the raw material, I can start it within few minutes, because my setup time is, I don't have to do anything. With the same tool head that I have, which is either a nozzle or a laser based or a metal laser head, with just changing the raw material, I can start that print. So the timeline is something which is very relative here. And as I said, if you apply this for mass customization, or maybe components where you are manufacturing batch sizes less, say maybe less than 50, 3D printing is going to be game changer for sure. So what they are doing is, now with a lot of companies, they are investing into something called as print farms. So with small 3D printers, they have 40, 50 or hundreds of machines. And all these machines are connected, they are IoT enabled, Industry 4.0, and they're connected to a server. So if you have, say maybe 100 components to be made, and each component is different, the queuing software is also, they are available. So you can actually send out all 100 files. Software decides on which machine, which material is already loaded. Based on that, it will kind of queue it up for each and every printer. And this is also possible. The way, we had server farms, or we still have cloud, right now we say cloud technology. I see now there are these 3D printer server farms, and there are companies building their APIs wherein you can directly connect to their printers and directly fire your prints and get it delivered within 2 days or 3 days time. Again, as I said, hybrid manufacturing we discussed about. So this also changes complete game, because now for a large fixture or a casting pattern to be CNC machined, it might take a few weeks. But with 3D printing and CNC machining both as hybrid approach, this could be done within a week's time or 4 or 5 days. Because now you're, as I said, you're making a near-net shape with 3D printing and machining it with maybe a CNC machine. Here again, there are customized softwares now. So because with earlier what used to happen is there was same CAM process, or maybe we call it slicing process in 3D printing, wherein we convert 3D CAD model into a language that machine understands, and it sends to the machine line by line. So earlier, same parameters were used for all sorts of components for 3D printing, but it can be customized as per your application, and then we can play a big role here for speed and scalability, because now with 3D printing again on a same single build platform, I can print 10 or 15 components with different designs, okay, without changing any tool, without any fixture requirement, and also optimize each and every component, 15 of them, for different settings, so that their strength can be different, their surface finish can be different, or their orientation can be different. And that's the beauty of this technology. So this is where it's a completely game changer for sure. So yeah.
Swapnil, can you also share some insights on lesser known challenges in adopting 3D printing, and how can they be addressed?
I think one thing a lot of companies do not know initially, or do not understand, or we also had a lot of took a lot of time to convince companies while they were adopting 3D printing, was if at all you want to go for manufacturing with 3D printing, you will we call it design for manufacturing. You cannot use same designs which you were using for, say, maybe CNC machining, or sheet metal based manufacturing, or so on and so forth, for 3D printing. So we call it design for additive manufacturing, DFAM. And so there are certain rules to it, and if you apply that, you can also build components which have more life, which can take more mechanical loads, or maybe can sustain in any harsh environment. Because a lot of times 3D printing is looked at being looked at as a technology which can which makes only fragile components, or it's only good for prototyping, but it can deliver end use components if you apply DFAM. So design for additive manufacturing is a lot of companies don't look at, and then they feel, or maybe even startups feel that okay, it's not good for us, it's not working for us, and that is, I think, one challenge. Secondly, material selection and validation. So as I said, these materials which are available widely, especially polymers, because polymers is much bigger industry in terms of numbers. I'll talk about that right now. A lot of companies don't understand that when I say ABS, 3D printed ABS and molded ABS is going to perform completely different, in a different way, in terms of the mechanical properties, thermal properties, even elasticity, or any other properties, because the process in mold, it's one homogeneous component, okay, and with 3D printing, it's a layer by layer process. So the material needs to be engineered according to the 3D printing process. So when a company says, I want a component that has to be made, or maybe my traditional component is being made in ABS, I might have to look at ABS plus, or maybe some other material which has some more additives, so as to I can actually mimic the strength, or maybe come close to the molded component mechanical or all the properties. So it needs to be very clear that what is it that we are expecting. And most of the times on the material data sheets as well, companies mention tensile strength, or maybe numbers which are given as molded and tested on the molded component, but not on 3D printed component. This material, even the data sheet, whatever it says, I think it needs to be tested after printing and then delivered. So this is one challenge many of the companies don't see, and they feel that okay, 3D printing is not working for us. Okay, we tried, but the part breaks. And a lot of them actually saw this happening, and we have seen them failing and saying, okay, we don't want to use 3D printing, it's not working for us. But this is the main reason why it is not working for you. Another thing is with the growing market, many of us in terms of companies which are into 3D printing and 3D printer solutions. It's our responsibility also to to communicate to the customer that there is a post processing requirement. After you 3D print the component, you need to post process it, so as to have get a good finish, or maybe you need color or you need processing. It's going to be different than your traditional processing methods. So these are certain areas, and especially cost analysis or ROI justification. You cannot, as I said, compare 3D printing with traditional manufacturing. Maybe with traditional molding or traditional CNC machining, your component cost is much lesser when it comes to mass manufacturing, and you need to be very sure where you are putting in 3D printing. Right now, with the current technology possibility, it can only be applied to customization or mass customization area only, or maybe when you have small batch manufacturing. But if you try to compete with mass manufacturing, it's not going to work out. The ROI issue is going to be there. Another concern or challenge that I see, a lot of people don't understand, is they send out designs directly without proper NDAs or documentation to online websites, where they don't even know who this guy is, where is he sitting, and they upload. In fact, I've seen many in good companies, there are software, there are basically portals where you can convert one file type to another which is used for 3D printing. They directly upload and download the other file type. But where is this file going? And what if there can be IP challenge. Okay, even if you're buying a 3D printer, or if you are going for a print service online or maybe offline as well, we need to check the credibility. We need to have proper NDAs. Also, some of the printers do send their data to the main servers so that they can be sliced, or components are sliced. So also a mandate from a machine manufacturer or reseller, and a very strong NDA documentation is something people don't see right now. But it's neat. This is a challenge, and we have seen issues around this. And I think more or less scalability. People or companies are okay to understand. They have certain products, but now they want to scale up, maybe. And at that point of time, with the 3D printing also, there is a possibility to build tooling. There are options in terms of applications. So maybe when you say vacuum forming, maybe fiber packaging, pulp packaging molds, or maybe if you are building one component, you can use methods like vacuum casting to build more similar components, say maybe 100, 200, 500. This is something a lot of companies don't apply, and they try and 3D print it, and they kind of feel 3D printing is failing them, or these challenges make them feel that 3D printing is not for them. But all of this definitely can be handled.
Swapnil, we've discussed 3D printing across industries and certain segments as well. Could you also tell our attendees who some parts of them would be from the construction segment? Could you tell us if 3D printing is applied in construction, and if you've seen any such case studies that 3D printing has been successfully used for the construction sector at large?
Yes, in many ways. In fact, there are a lot of projects for which I have seen companies from outside India working with Indian government to build a lot of rural, schools, toilets, and even remote small hospitals, or maybe I would say dispensaries. This is already happening right now. There was a time when, for construction 3D printing especially, the whole crux was developing. It was very important to develop a material that could cure that fast, because it's a layer by layer process. And a lot of companies have cracked it. The cost of construction 3D printing is little on higher side. But in terms of value, when we see what it can deliver, because I do not have to carry, a lot of equipment, or say, even raw material to the site, and that kind of brings a huge, advantage. Even in defense, where you have you need to have a tactical advantage in a particular area where you want to build a bunker or so. This kind of technology is completely game changer, not only just construction or concrete, but also having inside layers of insulating materials, having reinforcements and kind of structural rigidity that can withstand certain level of earthquakes or even granite blast is something which is being developed right now. So in a big way, I think this is coming through. I have not seen multi-story buildings being built over with construction 3D printing. This is more or less outer walls or maybe the inside compartments of the construction. However, I think this is also changing now with a lot of new development. There are a lot of institutions in India. They are developing a lot of such tech. Even academia is doing a lot of research, and joint development programs are happening with different education institutes and companies together. That is actually changing the game for construction 3D printing in India, and I'm very sure within the next 2 to 3 years, I think this is going to challenge the traditional method of construction.
Absolutely. Swapnil, I also want to check with you on what are the newest applications of 3D printing in creating lightweight yet strong components?
In terms of when you say newest applications, one that comes to my mind is, as I said, aerospace industry, because and space and aerospace engineering, because weight there is going to be a huge constraint. Even few grams would cost millions in terms of space and research. So lightweighting there is being done by a method called as topology optimization in terms of designing, where the software simulates the need, or maybe you can actually add in the load or kind of calculations that are required to calculate what will be the braking force here, and with some safety factors software can redesign it, reducing the material wastage and the weight also. So a lot of such components are being developed for aerospace and space. Also, I see this somehow working with two industries. Shoe industry, as I said, footwear, because if you just go online now, there are many big shoe companies. They are already utilizing this for insoles, and custom insoles also are being developed, where shoes are developed. The sole is lightweight and it's 3D printed, and rest of the component of the shoe is manufactured using traditional method. This is where again it's a completely game changer there for sports and shoe industry. Beyond this, also I think this technology is useful with defense right now, especially ship and navy components that are being developed. So this is actually area where most of the metal 3D printing happens, because that is where the end-use components are being developed more and more. And in polymer, it's more to do with healthcare and maybe consumer basically requirements, shoe or maybe spectacles and so on and so forth. But yeah, that's how it is going.
Okay, and what are the emerging trends in software for 3D printing, and how are they impacting design and production?
So I can see a lot of development happening with AI coming now, and so softwares can now analyze the design, can actually give you data on what kind of parameters can be put in. You can select the areas where you need better surface finish, and you can select the areas on the component where you might need more strength, and software actually decides the parameters. Earlier it used to be very difficult, and with such softwares now CAM, or the pre-processing of the 3D file for 3D printing, can happen in few minutes than few hours that it takes on a traditional manufacturing CNC setup. These softwares also can predict for any shrinkage or warpage that may happen after 3D printing, and correct the model accordingly, so that after the shrinkage or maybe warpage, the component comes back to the shape which was required within given tolerance. So this is there. And beyond this, as I said, for print farms, these softwares can queue up prints, because most of the users would love to have, or if at all you have a service bureau or maybe you're running a big print farm, you would not want to change the material all the time again and again. Say maybe if you're running on a metal 3D printer, you're running with a stainless steel, you do not want to go for aluminum, because that is going to be a big process, removing all the powder and then putting in new material. Similarly on polymer material also. So the software knows which machine has which material running, and it can actually queue up. This is also happening, and these softwares, or the server can be connected to an API, wherein say maybe tomorrow you have a design studio or maybe product design studio wherein you want to create certain desk accessories or any components. You upload or connect that to this service provider's website through their API, and directly this design is being sent to this server. It can be packed, shipped, and delivered from there. And this is something like this model is there for a lot of websites now online, but this is now also happening for 3D printing.
Okay, and I also wanted to check with you, Swapnil, on how is 3D printing entering markets with traditionally high entry barriers?
So when you talk about, say, I'll give you one example. So hearing aids, like for to get into that kind of market, earlier there is you used to get 2 or 3 different types and sizes of hearing aids, and you can put it, and people with hearing disabilities can actually put that up and use it. But now getting into that market was so difficult, because the demand was low, or maybe every customer had a very different requirement altogether. Size, again, they were also looking at color, because it used to they want to keep it as small as possible, and the color needs to match with your skin tone and something like that. But with 3D printing now, this is very easy, because each component can have different color, different size, and you can develop a custom device for each patient, and that can be delivered. Now getting in here earlier was so difficult, and for a new player to come in, because a lot of companies who are already, or big giants who are already into this market, they were also they were providing this product as extra service, because I think the volumes were much lower and there was huge customization. And because this company was actually even though profit margins were low on this product, they were just dealing with this because of the brand or the awareness they wanted to spread around this brand. But now smaller companies can challenge and on this and win big, and I've seen that's happening already.
We'll be taking 2 audience questions, Swapnil. One is on how is 3D printing transforming the ability to localize production and reduce reliance on global supply chains.
So, as I mentioned, earlier also, that if I have a German car, and maybe it's from 1970s, and if I ask my German car manufacturer to send that component, or maybe any component that I need, even if they want to send it, it's going to cost me a lot of money to ship, and also if I get it here, it might take a few weeks or a month as well. However, 3D printing can actually let you these companies print this on the in the same location, and actually use this component. So when you say hyper localization, or maybe area where you can actually 3D print the component where it is required and when it is required, it becomes a game changer, because there is a new market. A lot of companies have come up with repositories of 3D designs, and these companies have connected their websites to print service bureaus in different regions. So now you can just go on these websites and say, okay, this is the XYZ component that I want. And they have libraries of millions and millions of these components, 3D file libraries. You can directly connect or download it on your printer, or maybe start on your own business and service bureau. And there is an opportunity now where you can 3D print this and service this to your local industry. It can be 3D printed, it can be hybrid manufacturing with 3D printing and CNC both, But this is opening a big door, because now smaller players also can actually take advantage of this technology, because with geographical distance, for these players to reach to the market is going to be much easier, and companies are going to own design IPs or maybe designs rather than owning inventories. And they will also, this is going to foster more collaboration and collaborative approach between companies. So the way businesses are going to happen in future, I think that is going to change completely with this.
My last question to you, Swapnil, is what lessons can businesses learn from industries that have successfully scaled their use of 3D printing?
I think first, understand the technology, how it works, and what can go wrong, and have your risk analysis. I have seen, with typical hype curve, a lot of companies started with a lot of big ideas, and they thought, it's possible. They invested in 3D printers and, printing technology in big way, but they could not sustain. So before you go live, understand the risk, understand the technology thoroughly. Secondly, the ROI or the cost, if that is known, very well known, then it becomes much easier to invest and take that leap. Start. A lot of these companies have done initial small trials through service bureaus or through one of two of machines, and then they have gone big. Third is, companies need to be flexible to understand that 3D printing technology can be a game changer, and it is a game changer for them, for many of them. However, they should be ready for design changes and alteration based on the technology, because without that, the whole process might not make sense for them. Fourth is, there are limitations in the material for 3D printing. However, if you know that your consumption is more than, say, maybe 100 or 200 kg a year, there is a possibility of customization, in terms of material also. And these services are now available. These were, earlier it used to be standard material, and all of the printer users, they have to use same material. But customization is possible, and that can be asked for. And one last and important part, I mentioned this before, but I'm mentioning this again. That don't ask for the same material on 3D printing. Ask for the same material characteristics that you need, mechanical properties, thermal, electrical, whatever. Mention it very, very clearly. I think these are very small points, but they make big impact on the end result. And I've seen a lot of big companies coming up with a lot of enthusiasm, and they were so happy and they were so curious to try 3D printing, but then many of them lose spark in the end because of these things that they don't check. And the companies who have actually understood this part, they have done really good, and I've seen them not only the top line but bottom line is also amazing for many of them. In fact, they are growing back to back. So yeah.
With that, we've come to the end of today's episode. Swapnil, thank you so very much for sharing your insights and intel with our audience on how 3D printing can unlock business potential for them in both manufacturing and construction sector. Thank you so much.
Thank you, Amrita. Thank you for having me here.
For our audience who's online, if you've missed any part of current episode, or if you'd like to see this episode again or any of our previously shot episodes, please go on YouTube, type GSW1 MSME, and you'll find all our episodes uploaded there. Thank you once again, Swapnil. Bye-bye.
Bye.